While large language models like GPT-4 have revolutionized the field, relying solely on them isn't sufficient for a deep dive into AI because merely being able to interact with existing models like LLMs is probably not enough if you're looking for a career switch into AI. In fact, you must have a comprehensive understanding of the underlying infrastructure and the components that play the most important role while using AI and LLMs. In this short video, we'll focus on embeddings and vector databases, and I'll demonstrate using a vector database called FAISS and how it can be used with Python to conduct text and image similarity searches. Now, understanding vector databases and embeddings is crucial as they have grown into popularity in the world of AI. And this is because the synergy between vector databases and embeddings is what is sparking the latest advancements in AI. So before we get started with the demo, let's understand some basic definitions. To begin with, what are embeddings? Embeddings are high-dimensional data in a numerical form, which are also known as vectors. And these vectors are created from unstructured data like text, images, videos, or even audio files. And these vectors capture the contextual meaning of the data. On the other hand, vector databases are specialized storage systems designed to handle these vectors efficiently. Now, vector databases are not designed for transaction data or structured data even. They're specifically designed to efficiently store, manage, and retrieve vector data, which is inherently multidimensional and often requires different types of queries and storage optimizations. So what's the role of a vector database in the world of AI? Firstly, they provide efficient storage, allowing us to store vast amounts of high-dimensional data without compromising on speed. With these databases, you can perform similarity searches, identifying which items are most alike, which is a key function in recommendation systems and even content discovery, right? These databases scale with ease, handling more data without a significant drop in performance. And speaking of performance, vector databases are optimized for speed, ensuring quick retrieval of information. Lastly, they facilitate advanced analysis and operations, allowing us to perform complex queries and analytics that are fundamental in extracting insights from the data. Now let's take a look at some examples. So as we know, a vector is essentially a set of coordinates, and each coordinate or element within this vector corresponds to a specific feature or attribute of the data. Now this allows us to represent complex data in a simplified yet highly informative numerical format. Let's look at some examples. Take the phrase, "the cat sat on the mat." Now when we convert this sentence into a vector, we get a value of which is an array of floating point numbers, which is 0.7, negative 0.3, and 0.4. Keep in mind this number is only for the sake of demonstration. The actual vector will be very different. Each number in this array encapsulates a feature of the sentence, from its semantic meaning to contextual nuances. Similarly, a dog lay on the rug translates to 0.6, negative 0.4, and 0.5 in its vector form. Notice the subtle difference between the vectors of this sentence and the previous one, reflecting the slight variations in the meaning. Lastly, you have "she read a book in the park" becomes negative 0.2, 0.8, and negative 0.5. Now this vector is distinctly different from the others, capturing the unique elements of this particular sentence. But vectors aren't just for text. They can represent any data type, including images. For instance, a scenic landscape could be represented as a more complex vector that you can see on the screen. Through vectors, we convert raw data into a language that AI systems can understand, paving the way for operations like similarity search, classification, and clustering, essential for the next generation of AI applications. Now, there's quite a few popular databases that people have started using lately along with an LLM. First is FAISS, developed by Facebook AI Research. It's renowned for its efficiency in searching for similarities in large datasets, particularly useful in machine learning and deep learning. Next, we have Pinecone. Some of you guys might have heard of it. It's quite popular lately. This is a service that's making vector search scalable and accessible. Redis has also stepped into the vector space with its vector similarity search, which allows quick similarity scoring and matching within their vast database ecosystem. VV8 is an open source vector database designed for scalable vector search with graph and semantic search capabilities. GCP or Google Cloud offers Vector AI Matching Engine, or now known as Vector Search. It's a managed service designed for high-scale, low-latency vector similarity searching or matching. And finally, you have AWS's Elasticsearch service with its KNN feature to perform efficiently similarity search on billions of documents. In this demo, I'll show you how to install and use FAISS along with Python. Now let's quickly take a look at this diagram, which illustrates the transition from raw data into actionable insights in AI. So on the left-hand side, we have different types of data. We have images like landscapes and cityscapes, as well as textual data represented by documents such as PDFs and Word files. Each of these pieces of data is transformed into a numerical format or embedding, which is a fixed dimensional vector shown here in the brackets. And this can be done using open source libraries in Python. There's several of them. These embeddings capture the essence of the data in a form that computers can process. Now the magic happens when these embeddings are stored in a vector database. With our data now in vector form and stored in the vector database, we unlock several powerful AI operations. At the top, you see similarity searches, which enables us to compare vectors and find out which pieces of data are most alike. Now, this is a crucial function in systems like recommendation engines. Next is classification, where these embeddings help us to categorize data, for instance, tagging images or sorting documents by topic. Lastly, we have clustering. Here we group embeddings to identify natural clusters in our data, enabling us to uncover patterns or groupings without needing predefined categories. This entire process, right from converting raw data to embeddings, then storing these embeddings into a vector database, and onto AI-powered analytics, is foundational for modern AI applications, driving the intelligent solutions that we rely on today. Now, let's look at 4 key applications of vector databases in AI. Firstly, you have chatbots. Now, these digital assistants use vector databases along with LLM to understand and respond to customer queries on websites and apps, providing quick and relevant product information. Next up, you have product recommendations, where e-commerce websites and applications leverage these databases to offer personalized product suggestions that resonate with users' preferences. For image and video retrieval, vector databases are invaluable. They power the backend of stock photo sites and digital media libraries, enabling users to conduct searches for images and videos by using visual samples as reference points. Lastly, in the realm of music and audio search, services like music streaming platforms use databases to analyze users' listening patterns. This analysis is used to create features like Discover Weekly, if you use Spotify or any other streaming platform, curating new recommendations that align with the user's tastes. So that was vectors and embeddings in a nutshell. Next up, we'll start with a demo using Python, and you can find the code base for the demo on my GitHub repo, which is called Sit on Cloud, and the name of the repository is Python FAISS demo.